Good evening, everyone. In this video, we'll be talking about state diagrams. So, a state diagram is a graph whose nodes are the states. We have discussed about states in the previous video, and whose directed arcs are the transitions between the states. We even have seen a basic example with the states and then these transitions happening between the states. Okay. So, thus the diagram actually specifies the sequence. Okay, the state sequence. Okay, how the states are actually going across. Okay, so state sequence caused by the event sequences. Okay, so the events are coming, so how the states are actually changing in sequence based on the event sequences. That's what the state diagrams will actually specify. Okay. Within a state diagram, the state names must be unique, okay, within the scope of a single state diagram. So that is something to remember. All objects in a class, okay, execute the state diagram for that particular class. Okay, state diagram exists per class. We have already discussed, and all objects in that class actually execute that state diagram. Okay, so in that way, the state diagram basically models that common behavior for that particular class and its objects. So that's about the state diagram. A state model actually consists of multiple state diagrams. Okay, one state diagram for each class, so which I have been telling. Okay, with so you will not be modeling for each and every class, but then with the classes with the important temporal behavior. Okay, so the classes which have this important temporal behavior, you will be designing this sort of state diagrams for them. Okay, so that's all these state diagrams collectively form this sort of state model for that particular application. Okay. So which of the classes are important? Okay, or which of the classes have important temporal behavior? Okay. If a class has several states, okay, so if class with more than one state, it has important temporal behavior, because eventually what is happening if we have several states, okay, so basically with certain events it is moving between different states. Okay, so that class is important. Okay, so it has important temporal behavior. So with time its states change. Okay, so that means we have to draw the state diagram for that class. Okay. Suppose if a class has a single state, even then sometimes it may be very important, temporally important. Okay. Even if it has single state, but with multiple responses, so it has multiple responses to events. Okay. So for example, it will be in a single state. If some events comes, okay, so it will have multiple different types of responses. Even then, such a class is temporally important. But then, how do you represent a single state in a state diagram? Okay, so it will not be carrying much meaning there. Okay, rather represent such states, okay, single state diagrams. Okay, state diagrams with single state in a simple non-graphic form. So we already have seen how a non-graphic form of text can be there. For say, for example, if you remember from the previous videos, we have seen the alarm. Okay, so the clock in alarm ringing state. Okay, so similarly, you can represent for that particular state. Okay, and then so that's all becomes the state diagram for that particular class. So we already have seen that stimulus response table, how different events comes, what happens, what would be the output of it. Okay, so what will be the response based on that one, and then we will also have these sort of guard conditions we have seen. Okay, so in that particular description. So this is about a single state diagram. Okay, but say for example, if there are multiple state diagrams are there, okay, these state diagrams actually interact by passing events and through side effects of guard conditions. Okay, so these interactions and those things we'll be discussing in the next videos. Okay. So as far as this video will be focused, we'll be looking at the basic state diagram. In terms of the UML notation for the state diagram is concerned, okay, so it basically you will be showing the state diagram within a rectangle. Okay, and then you will have the name in the upper left corner. Okay, a small pentagon tag will be there in the upper left corner. I will be showing the figure in the next slide. Okay, and all the constituent states and transitions basically lie within that rectangle. Okay. So here is a state. Okay. So for example, state diagram. Okay. So which is for phone line. Okay. Telephone line basically. Okay. And you see like it is a rectangle with the pentagon appearing in the top. So that's where the name is actually existing. Okay. So it has several states and it has several transitions. Okay. So for example, like the phone line, in the beginning, like it will be in idle state. Okay. And then like if you lift the phone, okay, so the phone is off the hook. Okay, so don't think of your mobile phone, but then like rather think like the landline phone. Okay. So this phone line is actually the landline connection we are talking about. So that means like if you have it in the idle state, if you basically lift the phone, then that is you are pulling it off hook, okay, then you will hear the dial tone, isn't it? So that is the state. So the current phone line is in the dial tone state. And like if it times out, like say for example at that particular thing, like it comes as warning, or like if you put the hook down after the warning, or like after certain timeout, okay, on hook, so you basically put it back, okay, so then you will move back to idle state. In fact, you can be in any of the states, and then like if you basically put the hook, okay, so literally almost all the states, like if you put the hook on the phone, so the phone goes into the idle state. Now coming back, like if the phone is in the dial tone state, because like you basically lift it up, and then like you are dialing the digit, okay. So until then, like it will be in the dial tone, but when you start pushing the first number, okay, digit n, okay, it will be moved to this sort of dialing state, okay. And then like you have to enter multiple numbers. So even though you are actually entering multiple numbers, okay, so it will be in this sort of dialing state. Again, like if there is timeout comes, then basically warning, and then like it will go back. Okay, so that's a separate case. Okay. But say for example, after certain numbers you have dialed, if it is a valid number, then it will be moving towards this sort of connecting state, isn't it? So the connecting state, like there can be multiple events which can be actually triggered. Say for example, like if the other number is busy, then you will be moving to the busy tone state, and eventually you will go back to the idle state if you put it on the hook. Okay. Or else like even the line can be busy, not just the phone. Earlier, like we used to make the trunk calls. Okay, so probably many of you don't even know. So you basically dial, and then like the trunk basically sets like the call out. Okay. So then you will listen a specific type of sound like fast digit tone. Okay. So most often like you don't care about these things because you don't know about them. Okay. So eventually assume like if it is connected, if it is a valid number and if it is connecting, and if it is routed, then it will be ringing. See, first thing is like you are trying to connect, okay, and then like if it is routed to the other phone, like the other phone is actually ringing, then you will be listening to the ringing tone, isn't it? So you are in that ringing state. So if the other person basically answers your phone called phone answers, okay, so then you will be in the connected state, okay. So once this you are basically your basic call is finished, the call phone hangs up, okay. So then it is in disconnected state. And from the disconnected state, literally from almost all the states, like once you put the hook back, so the phone line basically goes into the idle state. Okay. This is about the state diagram for this phone line. Now you know like basically how a state diagram will be. Okay, there can be different types of states, different types of events coming in. So this is what we have been discussing in the past 3-4 videos. Okay, so this is an example state diagram. Actually, we already have discussed this point actually. When you are designing the state, okay, a particular state, not all values of this class are important to you. Okay, so stewards do not totally define all values of the object. Okay, say for example, if we really go back and then see this one, okay, this state dialing includes all sequence of incomplete phone numbers. Say for example, if it is India, and then like if we are dialing a mobile number, so until you basically press 10 digits, okay, you will be still in the loop, and then like you have like several numbers which are not completely valid numbers, you are still in the dialing state. But eventually you have to save that number whatever you have dialed until then, so that like you basically verify it whether it is a valid number or invalid number. So in theory, like there are multiple numbers here, even though you save them, they will not affect the state. The phone is still in this sort of dialing state. Okay. So that is what like this is talking. States do not totally define all values of an object. Okay. So they only represent important states. Okay. If more than one transitions actually leave a state, then the first event to occur actually causes the corresponding transition file. Okay. There are more than one transition which is going from state A. Okay. So the first event which actually occurs will basically will correspond to this sort of transition. Okay. So the transition will be fired, then you will be moved to the next step. Okay. But if an event occurs and there is no transition which actually matches it, then the event is actually ignored. Okay. At the same time, like if more than one transition matches an event, okay, only one transition will fire. Okay. But the problem is the choice is non-deterministic. Okay, it depends. Every time, like it may choose something else. Okay, so you are not sure of it. Which transition happens? Okay, so you don't know. State diagrams can represent continuous loops or one-shot life cycles. The phone line which we have discussed is a continuous loop. Okay, so the phone line will basically will be in the ideal state and eventually it will be going through all the states and it will come back to ideal state. Okay, how it has initially begun like you would not care and then like it is in this sort of continuous loop. So it will be going to different states, it will be coming to the ideal state or like it will be ringing, whatever it is. Okay, so it will be in any of the states, but the point is like eventually it will be continuous loop. But then like one-off state diagrams, okay, so are also very important. Okay, so one-shot state diagrams represent objects with finite lives and have their own initial and final states. Okay, so for example, like let us look at this chess game. Okay, so this is the chess is this sort of state diagram's name. Okay, we have this sort of initial state. Okay, this initial state is entered on the creation of that particular object. Okay, creation of an object. So you have this initial state, and then like from there, like the first state, which will be the transition, which happens is like it's white's turn. Okay, so the chess game is happening. Once the white's turn finishes, okay, so white moves, then it will be black's turn, and black moves. So this game will be going on like this one. Okay, so after certain number of moves, either it will be a stalemate. Okay, so then it will be more or less a draw. If any of them basically makes a stalemate, then it will be made. But the point is like if it is checkmate, then he will lose actually. Okay. So for example, if it is white's turn and then like if it is the transition is a checkmate, then he basically loses. Okay. So that's about this sort of having this sort of initial state and then like this final state. Initial state will be like represented like this. The final state will be like this bullseye. Okay. So an object basically enters its initial state, okay, when its creation. So entry of the final state actually implies like the destruction of the object. Okay. If we are basically thinking about this chess game, so basically like the state will be here is the object started. Okay. So here it is killed. Okay. So until then, like it will be in this sort of two different states. So this is about one short state diagram. There is also an alternate representation for this sort of one-shot state diagram. Okay. We can also indicate this initial and final states via entry and exit points. With the same state diagram, okay, so you can have this sort of entry points, okay, and you can also give the name for this one. So basically like start entry point, which actually leads to this sort of white's turn. Okay, and then like whatever we have discussed, like after his turn, like white moves, so basically then it will be black's turn, and if black moves, then it will be white's turn. It will be basically going on like this. Okay, and then like eventually I already explained it in the last slide. Chess game eventually ends with one of these three possible outcomes. Okay, either the black wins. Okay, or so if it is a stalemate, then it is draw happening. Okay, so for example, the way like I said. So if checkmate happens, okay, for white's turn, okay, so at the event is checkmate, then basically like white loses, so the black wins. Okay. So the same way here it is like white wins. So in this alternate representation, entry and exit points basically appear on the perimeter of the state diagram. Okay. So this is about the state diagram. So we have seen like both this sort of continuous and one-shot state diagrams as well. Okay. Hope this is clear. So as far as the reference is concerned, like we are still in chapter 5 of this book, Object-Oriented Modeling and Design with UML. Okay. So thank you very much for your attention.